In this lesson, we will be looking at the graphs of a couple different functions using the TI-83 or even the 84, and then we'll be looking at how can we use our graph or our calculator to determine different aspects of the graph, such as maximums and minimums, or even limiting values. For our first example, we have a function that gives us the number of passengers boarding an airplane at the Raleigh-Durham Airport. This can be modeled by our cubic function here. So n of t equals a negative 0.0123 t cubed plus 0.1975 t squared minus 0.8319 t plus 5.2471, where n is in millions of people and t is the year since 2000. And we will specifically be looking at the years, the x values from 1 to 10. So that's from 2001 to 2010. The first thing we need to do is go to the y equals screen and type in our formula. Now that we have our formula typed in there, we could go ahead and graph it, but it would probably be a good idea to start first by setting up the window. And there's different ways we can set up the window. Let's just start with looking at the window. Right now, and this is zoom standard, it starts with negative 10 to positive 10 for both the x and the y. Now we do know that we have a restriction already for our domain that it has to be from 1 to 10. So this first value, x min, can be a 1. Now we don't know what the y values are. If we look at the y-intercept of our function, it's around a 5. So that can maybe help us determine what the y-min and max could be. We could also just do zoom fit. Let's try zoom fit, which is zoom, hit the zoom button, and then 0. Alright, so the graph that we get, it starts somewhere in the middle. Again, this is for 2001, and the graph decreases down to a minimum, down to a valley or a trough here, and then it curves back up. And remember, the entire time it's concave up here, and at some point in time it flips concavity, and it continues increasing to a maximum, to this peak, and then it curves back down, so it's concave down throughout the second part. So now that we have this graph, what can we do with it? Can we determine how many people boarded a plane at RDU in the year 2001? Well, 2001 corresponds to t equals 1. So to determine that value, we can hit the trace button, and that puts a cursor on the graph. We can use the left and right arrow keys to move that cursor wherever we need it, or we can just type the number we want. So in this example, we want number 1. So press 1. So if x equals 1, press enter, and it will determine the value for us. If x equals 1, the y value is 4.6. So in 2001, there were 4.6 million passengers who flew out of RDU. Can we compute and interpret the meaning of n of 7? This time, 7 is the x value. So again, we could move the cursor using the arrow keys, or we could just type in the number 7 and hit enter. And it again will compute the value for us. So after the 7 years, so in 2007, there were 4.88 million passengers who flew out of RDU. Can we determine in what year the fewest number of people boarded planes at RDU? So this is what we call a minimum. It's the fewest number. Looking at our graph, it's this lowest point on the graph. It's this valley, or the bottom point of this valley. So to compute that, we could use the cursor, same way we've been doing trace, and we just could move it down to the left. But using the trace tends not to be very accurate when doing this. So instead we can go into the calc menu, which is second and trace. we have a number of different computations we can use here. For this time, we just want to do number 3, which is the minimum. When it does minimum, it asks for a left bound, it's going to ask for a right bound, and then a guess. The left bound is just, we need to tell the calculator how far to the left to look, so it's somewhere to the left of the minimum. And then again, we have to tell it someplace to the right to look, and then the guess can just be kind of anywhere in between. So to find that left bound, I can use the arrow cursor to move it all the way over there. I could also just type in a number that I wanted to use as a left bound. So in this case, I could have typed in maybe a 1 or 2 for the left bound. So there, that point is to the left of the minimum, which is kind of right around here. Press enter. It now asks for a right bound, so move the cursor back to the right. And I just want it somewhere so I can see that it's to the right of where the minimum is. Roughly there's good. Press enter. And we have these two little markers up here telling me that the calculator is only going to look between these two endpoints. It's not going to look anywhere else on the graph. For a guess, just hit enter, and it'll use that as a starting point. And it will eventually tell us that the minimum occurs after 2.88 years. So what this means, again, is in the year 2002, the minimum number of people who flew out of RDU was roughly 4.2 million people. Can we also compute the year when we had the most people who boarded planes at RDU? And this is the same thing, but instead of finding the minimum, we're going to try and find the maximum. So that's the peak up here. And the process is identical. So we're going to go in the trace menu, or the second calc menu. And that is this time going to be the maximum, so number 4. Again, we have to set a left bound and a right bound. So we can move the cursor over, or I could again type a number to set the left bound. Okay, press enter. And again, we can move the cursor to the right. This time I'm just going to press, I think the maximum is less than 9, say. So I'm just going to type in the number 9 and hit enter. And if you notice, that's where 9 is. So it's going to look somewhere between this left endpoint and this right endpoint. Just pressing the numbers can be a little quicker than using the cursor. So we'll go ahead and hit enter for our guess. And it will take a second, and it computes that after 7.82 years, it will hit a maximum. So again, this is during the year 2007. There was roughly a maximum of 4.94 million people who flew out of RDU. Let's look at another example. This time we have a cleaning crew. They discover a dead body in the morning, and they call the police to investigate. And the function that we have represents the temperature in degrees Fahrenheit of the body after T hours. T hours since the police arrived. So let's go ahead and graph this one. We still have all the information from our last graph, so we're going to need to go in our y equal and clear that. And then let's type in our formula. Okay, now that we have the formula typed in, we need to go ahead and set up our window. For the window, we don't need to start at 1 to 10. We don't really know what to set these to. We know T or X does represent the hours since the police arrived, so let's just start at 0. And maybe let's go for 1 day, so for a 24-hour period. Let's do zoom, and this time we're going to do zoom fit again. Okay, looking at the graph, we can see that it looks like it's concave up because it's decreasing at a decreasing rate. And if we think about this, it might mean that we have a limiting value, because it looks like the graph may be beginning to level off. So we need to look at that. Does it level off? To do that, we need to think about limiting values. So can we determine the limiting value of this function? If you think through just the algebra of this, you probably should be able to figure out what the limiting value is. But let's also look at the graph. Okay, so graphically, the limiting value, again, remember, represents x or t going to infinity. So if we look at our window, right now t is only going from 0 to 24, so we need to go for a long period of time. So let's say it's they let the body sit there for 100 hours. How is that going to change the graph? So let's do zoom and zoom fit. And we'll see that the graph has a very steep decline at first, and then it looks like it's almost beginning to level off. So that again does represent this decreasing at a decreasing rate. The question is, where is it leveling off at? Again, the graph right now is only between 67 and 88. Let's change the window a little bit. Hopefully the body is not going to drop below 0 degrees. So let's look at the graph now. So down here is 0 degrees, it's the x-axis. And if we look at this, it definitely looks like the graph is coming down and it's really beginning to level off. So the question is, where is it leveling off? This is going to be our limiting value. If we try trace, after 50 hours the body would have been down to 67 degrees. And if we continue moving right, it's getting closer and closer to just 67 even. These decimals are getting smaller and smaller. So it looks like as the body temperature, or as time passes, the body temperature would approach 67 degrees. We could really go overkill here, and we could go out, say, maybe 1,000 hours. We can definitely see the graph has leveled off. And again, if we do trace, after 500 hours, it's down to 67 degrees, and that looks like that's where it's setting at. So the limiting value of this function, we can see graphically, is going to be 67 degrees Fahrenheit.